How efficient is your production facility? If you were asked to increase production in your facility by 5% or 10%, could you? How do you know what impact that would have on your facility? Even the most efficient production facilities can hit unexpected bottlenecks when ramping up production. ProModel Process Simulator is used to model, study, and optimize a wide variety of manufacturing processes for existing brownfield and brand new greenfield projects. By visualizing and animating your production process, you can better understand what your process really is, rather than what you assume it to be. By simulating your process, you can optimize production line performance and identify potential bottlenecks before they occur on the factory floor. Using the familiar tools in Microsoft Visio, ProModel Process Simulator can build a digital process model of your facility using your mechanical equipment designs saved in your asset library from Autodesk Factory Design Utilities. Build a model of your factory process using the familiar drag and drop interface in Microsoft Visio, adding products, routes, and processes to replicate your work cell or production line. Assets from your Autodesk Factory Design Utilities library can be used to define the machines or stations that entities in your process line will pass through. Entities in the simulation represent the raw materials or parts that will be processed in your facility. Routing rules determine the next location for processing entities. Move logic determines when and how the entities can move to the next location. And operation logic defines what happens to an entity when it arrives. Resources represent additional equipment, devices, or people that support your production line. For example, loading and unloading components, quality checking, or maintenance. In this example, we've just finished modeling our production line in ProModel Process Simulator. We'll run a baseline simulation to ensure that our process model reflects our facility's current output. The animated simulation helps us to visualize our current production line process to better understand how it's functioning. When the simulation is complete, the ProModel Output Viewer allows us to build a dashboard of reports from the simulation analytics to focus on the metrics that suit our business goals. In our example, our business has asked us to grow production by 30% over the coming year. Using our simulation model, it's a simple step to add alternative scenarios to our simulation and rerun the analysis to compare the alternatives with our current baseline. Comparing the desired increase in production to our baseline analysis, we can see that the current production line will hit a bottleneck at the thread cutting machine, preventing our production line from reaching our required increase in output. But this doesn't worry us, because we can now use our process model to compare upgrades to the production line to find the most cost-effective way to remove the production bottleneck and meet the uplift in output. In our example, the bottleneck is at the thread cutting machine. But what's the cause of the bottleneck? To answer this question, we can compare the addition of an extra worker with the addition of an extra thread cutting machine, or the addition of both. Our baseline report shows us that the thread cutting machine's buffer has a high number of components in it. Showing the alternative of adding an additional thread cutting machine, we can see this doesn't solve the problem of the buffer being full and has no effect on the throughput of the production line. Showing the addition of an extra worker, we can see the worker can clear the buffer and remove the bottleneck, which is good news. However, the throughput for a single thread cutting machine has only increased from 278 parts to 310, a 12% increase, but below the 30% that we've been tasked to find. Our final scenario compares the addition of both an extra thread cutting machine and an extra worker. In this case, we can see the worker can steadily clear the buffer of both thread cutting machines, increasing the throughput from 278 parts to 376 parts, an increase of 35%, well over our 30% target. In this case, we found that the optimal solution is to add both an extra operator and a new thread cutting machine to remove the bottleneck and increase production to meet our target. Not only do we have an answer to our problem, but we have the analytics to demonstrate how we found the solution and make our case to management for a new hire and capital expenditure to meet our desired production target. After completing the process model, you can save your team rework and effort by exporting the Autodesk factory design utilities assets used to build your process model to AutoCAD or Inventor, where they can be used to create a physically accurate model of your production line. Your team can now use the 2D AutoCAD model to lay out the production line, along with additional requirements such as material handling and movement routes, within the real-world coordinates of your facility. The bidirectional sync between AutoCAD and Autodesk Inventor automatically converts the 2D AutoCAD layout into a three-dimensional model, helping you to coordinate physical clashes between the process line equipment and the building envelope. In Autodesk Navisworks, your 3D model can now be combined with your project schedule to plan and simulate the installation process of your new or revised production line, helping to prevent on-site delays and reducing the need for contingency budgets. Digitize your production facility and turn change from a risk into an opportunity by planning, validating and optimizing your production facility with Autodesk Factory Design Utilities and the ProModel Process Simulator.